Hi, everyone. Welcome to another episode of the Lisp Study Group. I'm your host, Ram Vadam with Atlanta Functional Programming. To my regular viewers on the YouTube stream, I apologize the last couple of weeks. Unfortunately, due to some technical problems, I was forced to kind of upgrade my computer to a newer OS, and I had to spend the next couple of weeks and then uh, kind of looking around to resolve some issues related to being able to stream. I think I resolved the majority of those issues, so hopefully your viewing experience will be good on the YouTube side. Um, Today, I wanted to kind of touch base on a topic that I've been kind of thinking about on and off the last almost four months now, just mainly because it's a topic that I've been reading up on just in general, and that is the concept of method combinations inside Common Lisp. This is a topic that we've covered in previous episodes in various shapes, one of which was we covered a research paper a while back on actually implementing a certain type of dispatch inside Common Lisp using method combinations. And we also looked at the possibility of like leveraging that over the meta object protocol that's available inside Common Lisp too, because with the meta object protocol, you do have the ability to do some of the kind of method dispatching sort of mechanism that method combinations give you without having to write a full-blown method combination rule, if you will, into Common Lisp and then have it register as part of your library load and as a result, ultimately, it leads to more maintainable code because there might be some situations where your dispatch mechanism might override something that most people aren't used to because with typical object-oriented common Lisp, you already have this default dispatching mechanism available to you, which is most specific to least specific for a given object hierarchy. So today I thought we'd go through and actually cover the concept of method combination in detail, also how it relates to what we've seen in the past and what we've explored in past episodes, and hopefully provide some examples of real like method combination use case studies that you might end up preferring over, say, doing a full blown out extension that you could write with the meta object protocol. As usual, to many of you who are watching, uh, Atlanta Functional Programming is a meetup that kind of promotes just the use of functional programming and functional programming practices. We are in search of new talks and topics. It doesn't have to necessarily be a direct application of FP, could be any functionally oriented topic that you may choose. If there's a topic that you're interested in presenting, please feel free to reach out to me. I am available as Bugram on functional programming Slack, as well as I also squat in the Lisp Discord server that's available for folks who want to reach out to me there. Just mention what topic that you're interested in presenting, and then obviously we can work towards scheduling you in. Additional announcements, and I know this has been taking a while, but AFP is in search of a new home for our in-person meetups. Um, Please reach out to either me or um, Judd Taylor, my co-organizer, and we'll get back to you as soon as we can in terms of actually, scheduling some time to, reach out and see your facilities and stuff. We are mainly looking for, some ability to have, a projector so that folks can actually give tech talks and then work towards, having more networking and meetups in the Atlanta area. Finally, I want to also mention that AFP is actually going on a real planned hiatus for a couple of weeks in July, starting with the Independence Day weekend, and then the week after that, up until the um, Saturday the 20th, essentially. So that would be, I think, 3 Saturdays for the month of July. Apologies ahead of time. Just planned events around that time, kind of preventing me from actually doing the stream in the early afternoon. Okay, so without further ado, let's dive right in. Let's first cover what is a method combination. This is something I've kind of talked about on and off in uh, various episodes. And again, we did cover some of this basic stuff, so this might be review for those of you who have been regularly watching the stream. But a method combination is basically a way of configuring method dispatch inside of Common Lisp. So what does that mean exactly? Um, you have types. You could define methods using def method. Okay. But if you have a type hierarchy, obviously there's going to be some need for you to be able to specify how a particular method that's higher up in the type hierarchy gets uh, dispatched and actually invoked versus something that's lower in the type hierarchy. So what I mean by lower is if you have, the following dependency graph, um, hold on one second, there we go, where you have a object A that depends on an object B. I mean that actually not depends. It's really a object B that's a subclass of object A, right? So we know that A is the general class and B is the more specific class. And you have a method that you defined has, foo that depends on a object that's specialized to A, and then you also depended on, um, you created a foo definition that is specialized on instances of type B. Then what method combination does is it gives you the rules and provides you the rules to be able to say, hey, we want you to invoke, and then this is standard method combination, object B's method first before you go and invoke object A's implementation of foo. Okay. Um, in static languages, if you recall, what happens actually is when you do, you know, a class A. Okay, I'm just going to use C++ syntax here for without getting into too much detail with some sort of members. Okay, and a class B that, and let's actually do this. It's a class A with some sort of member functions, and then you have a virtual function void foo, all right, and a class B, and this has some sort of default implementation. Okay, let's just say that we just print out a dot foo here. Okay, and we have also, put a new line there, and we do a public inheritance of this in class B. Um, and in here we do, virtual void foo override, and we have our b.foo. What ends up happening is you have in one case, um, you have a V table that just gets created, okay? And this is the same even in Java and stuff like that. You have this virtual table that knows what the type hierarchy is, what the function is, how a function is going to get invoked, okay? So in this case, foo is going to get invoked. But in this case, what happens is that compile time is as we look up the instances method to see what implementation is available for us, and we end up actually uh, just calling that instances method. Okay, so in our case, we expect that b.foo will get called, all right? And then a.foo may not get called unless you explicitly call it. So like if you wanted to call it in static languages, you actually would do a colon colon foo here explicitly, and then you would end up calling, whatever adjustments you want to write. Okay. This is just for folks who aren't necessarily familiar with this concept. Okay. In standard method combination, this will happen for you for free. All right. There are ways for you to prevent that from happening with, like, think around methods. You can actually go in and actually say, okay, you need to change this so you no longer actually call the next method and so forth. But in general, standard method combination, what it tends to do is it'll do most specific to least specific. So it will end up calling um, the most specific case that you would want. And in a around method, you can actually go in and call and create your own tool chain. Now, this is standard method combination. With defined method combination, you could provide your own rules, all right? And providing your own rules comes with some um, obviously some caveats, all right? You need to provide the ordering in which you want to invoke this, all right? You need to provide the whether it's required or not, some sort of required P. You can provide things like whether or not it has an identity function with one argument. So if you pass in one argument, what can you do? All this kind of configuration is available to you inside of the defined method combination, and gives you the ability to actually go in and create a simple method combination that would end up uh, being invoked on your type hierarchy. All right. So to illustrate this, I'm going to kind of show, you know, the two forms that the method combination comes in. One is called the short form description, following what is inside uh, the hyperspec, and the other one is obviously the long form description. Okay. In both cases, the short form versus the long form, the actual invocation of the form is defined method combination. Okay. And this will take in a name that you want to provide. Okay. Like and in the case of the example that we're going to be creating. And it'll take in some additional arguments, like what I said, that um, would you want it to have identity with one argument? Okay. Would you want in the short form, you know, what is it, the actual operator that you want to invoke this on? Okay. And what this does is it will actually um, take these, and it will create a method combination for you, right? Now, by default, short form, um, this is just a macro, okay? So this defined method combination is just a macro. And if we go and look at the expansion of this macro, what it's actually doing is it is creating us this method combination um, for the ability to leverage it if we ever create two hierarchies for this. So in this case, what this method combination is doing is actually, I don't need to put that there. I can just put this in here. And hold on second. What is it complaining about? Lock-on combination because it's method combination. Oh, it's because of the fact that I am recreating something that already exists. Let's say we call this my and, okay? And we go and compile this, we end up getting the method combination, okay? And what this does is it will generate the and please notice that oh, I'm getting a double quote here. I have to fix one more thing. Looks like I'm going to have to do this operator and. Let's see if that works. Okay. And okay. Now this is correct. So the main thing to look at in this macro expansion is the load short defined method combination. This is actually a SPCL specific way of doing it. Different Lisps will obviously have a different load short defined combination. But the main thing to look at is the arguments that are being passed in. All of them are quoted symbols. And what's happening is what's going to happen is when you invoke this guy, the short method combination, it will end up looking up this symbol and then just running the function that the symbol is attached to. All right, no big deal. What is the order in which this gets created? Okay, so let's say that we create a couple of simple classes here. All right, let's say that we have an X class, okay, and um, we'll just say that this has no, we don't need any main things here. We'll go ahead and go this for now. And let's go ahead and do that. Oops. Um, right. I don't need this. Okay. There we go. And then let's go ahead and do define class, y class that takes in the next class. So from the standpoint of common Lisp, we have essentially X class being a subclass of Y class being a subclass of X class. Okay. Oh, right, because I forgot to say that this also doesn't have um, any. Okay, and that. All right. So we have X class being the base class, Y class being the subclass. Now, if we create a a new method here that, you know, let's say that we'll call this, you know, foo, and we say that it takes in my end, and then we will say that this obj be obj being X class. And I'm going to define the methods in just a second here, but I'm just going to go ahead and put in the boilerplate because we're creating two of these methods right now. And this is somewhat boilerplate because we're creating multiple of these instances for folks watching. And this is Y class. Okay. The first question that we want to ask is what is the actual order in which these are actually going to get invoked? And because this is the short form method combination, it's going to follow the same ordering as standard method combination. And what is that? What that means is you're going to end up invoking most specific to least specific. So most specific means is you're going to the leaf subclass in the class hierarchy, invoking that function and working your way up. Okay. Um, and in the case of this and method combination, what we're essentially doing is we are calling each of these methods, all right, and we're taking the results of each of these invocations and we're anding them together. All right, that's what the and method combination does. Okay, because that's what and does. And will take each result of each function invocation and and them together. So this is important just from the standpoint of the fact that you are essentially extending the functionality of the common Lisp system, not necessarily in this case because like it was mentioned when we tried compiling the AND method combination, uh, AND is already provided to you in the common Lisp package. But in general, when you go and do these dispatch kind of mechanisms, what you're doing is you're essentially expanding how or leveraging function invocation as a way of scheduling uh, particular types of actions depending upon how you are leveraging it. All right. And this is very useful, especially when you start going down to paths where you may necessarily want to dispatch in a type hierarchy different aspects of the invocation, let's say in a distributed manner. All right. Um, so your type hierarchy makes sense conceptually, but the runtime system that you were leveraging was unable to provide you a way of invoking this so that each particular piece could be run independently of one another. So, although conceptually the type hierarchy means that there's a dependency between them, really it's the state in which those they represent that makes them a group together, not so much necessarily the behavior that you need to run for a particular use case. Okay. Now, this seems all theoretical when you go beyond the my and or the and method combination. So, what is one example of how we might actually leverage this? Is obviously a good question, and this is a question that motivated me to start kind of like talking about what this is, because this is something I myself struggle with when I start looking at some of these advanced features of Common Lisp. And it isn't so much that the concept is hard to understand, more so than what is the correct way and when to actually apply it. Okay, because the idea of being able to control over how your methods are getting invoked in a type hierarchy in most modern languages, or most modern, what we consider modern languages, such as C++, Python, Ruby, and so forth, they came to the conclusion, well, the easiest thing to do is first simplify to the fact that if they wanted to go ahead and dispatch their base classes method when the subclasses method gets invoked, then they would do so explicitly and it would be a form of documentation. This is the argument that I've actually heard some folks say would be a good indicator of you are well, at least from the standpoint of code maintainability, their argument is well, we know by looking at the code what the how things are getting dispatched and when they're getting dispatched. My argument is from a design perspective, if the runtime system gives you a feature to be able to do that in such a way where you can actually concentrate on actually defining your behavior and you're only debugging it with the assumption that you know at a higher level the mechanisms of dispatch will take into account how you want to actually dispatch your methods, then the machinery will take care of the what we consider the boilerplate dispatching mechanisms and will do the correct thing for you. All right. So if you define your actual rule like we did here, okay, you're putting trust in the actual scheduling mechanism, dispatch mechanism to do its job. So you could concentrate on what really matters, which is the actual business logic for your application or for your object orientate your actual software design. Does that make sense for folks who are watching? I'm just going to pause for a minute. I know I provided a lot of information here, but so I'm just going to wait just 1 second.
Makes sense to me.
All right. So let's take a look at um, the. So this and will actually work the way we're kind of expecting it. So let's just quickly kind of show this off. We could go ahead and do format T. I'm gonna make really dumb logic here just because we'll pass in, you know, uh, some stuff. All right, so we'll pass in a value x here just to make things a little bit better. And x is just going to be just so that you could see things getting invoked. It will be useful for you to actually look at um, how this is working. So we're just going to go ahead and say we're invoking um, x class foo. Yeah. yeah, I'm going to just use notation here. I'm mixing notation. Apologies ahead of time for folks watching, but this is just a quick shorthand for me to actually kind of like show what we're doing here. Um, Actually, you know what? I could probably do it this. Be more specific. Calling foo on instance of class x class. Okay. And now what we're gonna do is to make this really dumb, I'm just gonna say x is less x is greater than 1 and would say x is less than 5. All right. Okay. That gets invoked. That gets this, and then let's go ahead and okay, and pull this up a little bit. Invalid qualifiers. Hold on a second. Oh, okay. So I'm gonna have to do this. I think this becomes a keyword argument. Did I do something wrong here in terms of let me try something here. Because if this works with normal and let's see what happens here. Warning, invalid qualifiers. Let's see. Huh, interesting. Okay. So this should be okay, let me just go ahead and see what happens if I do make instance of I class. Okay, foo star 3. Let's see what happens. No primary method for generic one called the arguments. That's interesting. Hold on, I may have screwed this up. I'm just reloading my project here. Give me a second. Load if p method combinations. Okay. Invalid. Let me do one thing. We also do this. Let's define a generic foo. I shouldn't have to do this because usually it automatically generates the thing, but to be more clean about it, I should technically do this. Documentation. Generic function for okay. Redefining. Okay, hold on. I'm gonna just start this again one more time. Okay, let's load method combinations. Go up and let's do that. And let's start again. We define our method combination. Return foo class. We define our foo object. We define that. Define that. We go ahead and create an instance of y class. Let's go ahead and also assign this guy to an instance. Okay, and now let's do foo inst, and what does it say? Still says that we are not defining something, no primary methods. There is something going on. How I'm dispatching it seems to be is something that it does not like. So let me just quickly look at something here. Ah, okay, so this is what I messed up. So when we define the generic function, I have to also provide the method combination upon which this is going to be. So I do method combination. Forgot about this my end. I think is what I need to do. Um, and we need to also specify the ordering that we want this to um, work on too as well. And this is going to be um, actually most specific first is what we want. Most specific last. Let's see if this works. What is it saying? Okay, 1 second. I may have corrupted my this happens sometimes. Let's see. What is it saying? Ooh. Oh, okay. I see what the problem is. I have to do this. I'm not supposed to provide that. Let's do that. There we go. Let's do quick. Okay. Let me just make sure that that works on normal load one more time. Okay, good. Let's try this one more time. So all this should be loaded because I just loaded it in. So I should be able to do diff parameter instance y class, and then we do okay. So we can see here because I didn't specify in line 35 where something gets invoked. Okay, the order in which we're going to be following is the same order that standard method combination provides. Okay, which is really nice. We don't have the fact that we don't have to specify how we need to do it when we're doing normal things and we're just creating quote unquote an extension to the current ways with the same dispatch semantics as standard method combination. The only difference between this and what standard method combination is doing is of course is we're anding all the results versus what standard method combination does is which is think of it like running every function in the type hierarchy like a schedule, one after the other. So to just loop through all of them. Okay. Let's say that we wanted to change this order. Okay. We could certainly do so by saying most specific last instead of most specific first, and it'll go in the reverse direction. Okay. Um, so now if I go and invoke foo.3, you see that the order has changed. We called X class first and then Y class. Um, this shorthand will solve maybe 80 to 90% of most people's day-to-day use of method combinations. Okay. And there's plenty of them out there actually. So you don't have to define your own in cases where like and the example that I gave right now already exists in the standard method. Well, the already defined method combinations that are available for you. Okay. St- So I'm being very careful here if you're noticing from using, say, standard method combinations, because there is a phrase that says standard method combination, and that just is very specific to taking a type hierarchy, invoking a function, most specific first, and then working your way up the type hierarchy to the base class by something called call next method that would then call the next method in the hierarchy chain until you reach to the top of the hierarchy. All right. And um, so there's a library of method combinations, and then there's also the standard method combination. Standard method combination also includes, if you recall, writing what are called before, after, and around methods. Okay. And what the method combination basically says is run all before methods, run all after methods, and then, sorry, run all before methods, then run all around methods, and then run all after methods. Okay, and being able to provide rules as to when you run each one of these sub methods gives you this nice flexible functionality of dispatching and calling object oriented methods inside Common Lisp. Okay, the and, or, list, append, nconc, and so forth. Um, all of these are already available for you inside um, Common Lisp, and you don't have to do much. And the nice thing about this is this makes it easy to write extensions on your methods in such a way that you could um, get the intermediate results and say monitor what your object hierarchy is doing during the execution of a particular um, uh, hierarchical function call. All right, and it allows you to pinpoint particular areas in debugging when necessary. And additionally, um, in the case of and or min max, you could compute in your type hierarchy particular values that you feel would be more important for your use case rather than keeping what some folks do, which is a base level cache of all the intermediate values and then doing some uh, secondary function call to actually go and take those results and then do something with it. All right. This gives you that flexibility ahead of time as part of the runtime system. Okay. I thought this was particularly interesting from the standpoint of method combination. What is it? Uh, Method dispatching inside Common Lisp. That I was thinking of other ways that one might leverage this. Okay, and that requires really creating new operators or new function calls, and then being able to um, expand on what is currently available for you. Okay, so I want to start with a basic um, like example that I want that motivated me to continue exploring this particular topic, and that is what's it? Progn. Okay. So for folks who don't recall what Progn is a form inside Common Lisp that allow you to run um, essentially expressions or function calls one after the other. Okay, so here we if we had something that just prints one and two, the order in which Progn would define this would be one then two. It'll run this one after the other. Okay. Let's say that you wanted to write your own um, parallel version of this. Okay, and you're not necessarily and what I mean by parallel is really concurrent. Because we're running this on a multi-core system. It probably could be parallel. It may not necessarily be, but it will definitely dispatch, say, different threads and then have them, run certain functions and then return results. Okay. Um, we could use method combination to actually generate the uh, calls needed to dispatch to different threads of execution, collect the results, and then present them to the end user. All right, and in this case, then you would have essentially a let's say a hierarchy of say um, workhorses. Okay, like that represents a workflow. Okay, and each individual um, subclass of this workflow will essentially do one piece of functionality that represents this. You could then use, say, a library like, say, L-Parallel, which gives you task-based communication to actually go in and dispatch this. I'm still working through some of the kinks on particulars on this particular design just to see how might we throw off because one thing in here is keeping track of the intermediate results from a particular thread of execution while others are still computing. So this actually occurs in situations like where you want essentially a barrier synchronization. You want all your threads of execution to actually go and complete. So you can gather the results and then present them to the end user, then move them on to the next stage of execution. So I'm still not entirely um, uh, through with my design phase on this particular thing. So I want to at least touch base and give you guys a brief overview on what this is doing and give you the notations between the short form and the long form before we actually go in and start going into this use case study here. This particular, well, it's not even use case. It'll be a case study on how to implement a extension, well, a method combination for L parallel like workflow dispatch. Okay, so let's go on to the long form versus the short form, so we can compare and contrast the two. We've already looked at. We could already see that the short form gives a lot for us. Okay, we have the ability to. Sorry, we have the ability to say, hey, we could run this with one argument. We could actually provide you the operator or function call they actually go and invoke. We have the ability to, and it will generate the rest for us. All right. If you're doing nothing but just basic stuff where you define a function, you just want the object hierarchy to take the internals and be able to call this function. All right, one at a time. Short form notation is probably the best you need. Okay, you do not need to deal with the long version. But I want to kind of go through the long version as well, just so that you are aware of what this is doing here. Okay, so again, the long version is basically starting with my method combination. I'm going to say we'll call this my and two. All right, we're going to still use and for this example. The first thing we need to provide is the optional argument on how to specify the order. All right, and the order here, sorry, the order here is most specific first. Okay, instead of most specific last, we've already seen most specific first or most specific last. Um, you have now the additional thing that you need to provide, which is you need to provide two additional things. One is essentially the what's it? The actual argument lambda list, and you need to also provide some additional predicates, some additional forms that people can leverage. All right. Um, so let's go through that. Okay. Uh, hold on one second. Oh, right, right, right. We need to also provide essentially a list of qualifier patterns because in this case, in our case, we are potentially going to use qualifiers like around here would be because we are essentially extending the standard method combination, we need to provide this information. Okay, and this is one, and then we need to also provide one more thing, which is, ooh, wait, I messed this up. One second. Let's do this again. Okay, around, like this. Now we could do primary is going to be and, okay, and then you're going to have to specify in this qualifier pattern the order in which you're going to provide and the whether or not this is required. Okay, So what is this piece here? This is basically extending in the long form standard method combination, which gives you um, primary methods, around methods, before methods, and after methods, as you all know, and it's telling the order in which you need to run these functions. These are called qualifier patterns, okay? And these are essentially extending what was already provided for you with this additional information, okay? So we need to do some form of setup, and I'm just showing off what the uh, bits and pieces of what the the documentation's going through, all right, based on my understanding of this. And for folks who are looking at this, who are wondering from the reference here is long form description from Common Lisp Hyperspec. So this following example came straight from the Common Lisp Hyperspec. And so we now have order, we now have advanced, and then we have to set up our let form, which will allow us to first create the initial form that we need to provide when we're dealing with primary methods. So the first thing we need to do is we need to say, okay, if the rest of what we have are primary methods, okay, then what we need to do is we need to generate the and expression for this piece of code, okay? And so you would first create something like this. And remember, this is a macro that we're defining. Define method combination is a macro, so we can actually use the back quote to actually go and define this. Okay, and what we could do is we can actually do a map car on the primary list because again, rest primary means that you have you actually have a list of primary methods that you want to go and invoke. And then what we're doing is we're calling um, call method on each of the primary methods that we have, combining the results and then passing them over to and. This, because and can take in multiple arguments, will then ultimately be essentially an all. Look at all the predicates that you have and just make sure that the results of all of them are true. Okay, so that's what this part is doing. Okay, and then this alone won't help us because we need to also call the method, right? So what we would now do is we have to go in and say, okay, now we have to call method on what now? The first of the primary methods. And this will invoke the chain that you're looking at, okay? So we do um, so now we have our form, okay? Now we have to provide the main thing. What are we doing in this piece now? Well, we have around methods. We could have around methods. So what do we do when we have around methods? Well, if we have around methods, we need to first call all of those before we actually call the actual form that we just generated, which means ultimately here what this is doing here is this is basically saying, okay, if this is the rest of his primary, if we have a list of primary methods, go ahead and them all. Otherwise, call the first method in this list. But if you have around methods, okay, what you want to first do is call method on the first of the around methods, okay, because it's going to be passed in potentially as a list, okay, okay. And then what we have to do is um, hold on, I forgot to this. This one is call method first round And then we have to also call the rest. One second. Here we go. We need to do this, right? Yeah, rest around. That gets all of them. And then we also add make method on the actual form. Okay. And what this is doing is basically it's calling the first around method, and then it's taking the rest of the around methods and concatenating them into this list of methods that need to be called along with our for method itself, right? If we don't have around methods, then that means we just need to run and call our primary method. A primary method must also be there, always be there, okay? So this is a lot of code, but most of it is uh, just macros that are getting generated. So we're creating a form of the and here if we have primary methods, okay? And then what we're doing is we're attaching any around methods to the primary methods so that all of them get attached and created at the same time. So this will hopefully be and then running each of the individual forms and stuff that we have before. Okay, so this is pretty much it. We have our method combination that if we combine and we load it, we can actually go in and then run our example that we have before. So let's go ahead and create um, another def generic. Let's call it foo2. This time we do documentation. Hold on, let me just make sure my notation is all right. I have a tendency of messing things up. Oh yeah, I have to make these keyword arguments. Okay, Mr. Documentation. Another generic function using long form method combination. And then we specified our method combination saying that it's my and 2, and we don't need to specify, see, we don't need to specify in the def generic. Oh, we could specify that too later. Okay. Okay, so now we could do this, and we could do def foo to my and 2. Okay. Okay. Being x class x format t calling foo to instance of class, and we'll say x is greater than 0 here, and def method foo to my and 2 on y class. And let's say x is less than 10. Okay, so we defined this guy, we defined this guy, and we defined this guy. And now if we do foo2 on instance, and let's say we do 3, what do they complain about? Invalid. Oh, I have to go in 1 second. That's because we've instantiated this guy before those methods were tacked onto it, so I have to redefine this. second. I must have messed up something in my method combination. Why is it complaining about this? Hold on. Did I forget the long form something here? Let's see. Um, there is something I'm missing. Hold on. Let me look at this. Invalid method error. Look at this guy here. Maybe there. See what happens. So this is creating all the special qualifiers. This is creating the and that we wanted with the specializers. And then just look at this guy too as well. Again, it says no warnings. Go and look at foo, because I created this function. Maybe I have to say most first. Okay. What is it complaining about? Look at the backtrace here. Invalid method error for method combinations. Let me see something here. Maybe I'm missing what. Method combination. So in here, I have to go look at the long form description again. It seems that there is a method group that needs to be looked up. Um, each method group specifier. So it looks like it's not able to figure out the primary method that needs to be invoked. Um, just give me a second here. I'm trying to figure out why that's the case. List of method if the name of a predicate function can appear instead of qualifier patterns in a method group specifier. The predicate is called for each method that has not been assigned to an earlier method group. It is called with one argument the method's qualifier list. The predicate should return true if the method is to be a member of the method group. Predicate can be distinguished from a qualifier because it's a symbol other than nil or star. Okay, so I'm going to look up in the long term. Description, order required. I see. So the problem is within my method combination long form. So the long form basically the problem that it's having is with this notation here. Why is that? So in order for this macro to recognize that we're doing long form descriptions, the argument after the name must be a lambda list, okay, as indicated by this. Okay. In our case, this here being an optional is mainly because of the fact that this allows us to specify a default argument for the order in which we want our particular method combination to get executed in. And that's what you saw me pass over in the method combination keyword argument when we defined this macro. Followed by this is something called the method group specifiers, which is something that I should have um, dug deeper into when we were discussing this, but now I guess it's a good time since we've hit this kind of roadblock. What the method group specifiers does is it allows you to take in a keyword argument that you may see in a dispatch chain and essentially gives common Lisp the ability to filter and group together individual methods of the same type into lists that it can then use to dispatch based on the order in which you want them to be invoked. Okay, and in this case, it's around methods first and then primary methods. Okay, but what's happening is even though I specified the method group specifier, there seems to be this situation with the and here with this notation that is throwing off common Lisp, which I thought I corrected when I was looking into this originally, but it looks like I didn't. So obviously we need to correct that. Uh, um, so let's just quickly look at this. This is and lambda. So, okay, so here, let's see if I can. Okay, I'm gonna redefine this. Give me a second here. See if I this was just a copy paste error from the example that I was reading through. Um, right at okay. See if that works. Shouldn't have to specify this actually. Let's see what happens. Still giving me the same error. Okay, there seems to be something incorrect with the example that was provided in the docs that we need to go and debug. Because this example here, this code that I'm illustrating to you that we're going through, um, this one came out of the docs. I thought I understood this when I was playing around with it yesterday, but looks like there is some issue with it. Um, I just didn't understand it at the time when I was looking into it. I don't remember how I fixed it. Let's see. Let me do this. Let me see something here. Let's try doing this. I'm going ahead and setting this up, and then I'm gonna try and load it into my image. Um, inst 3m. Okay. Okay. So it has a clear problem with adding this into a method group. Okay. Why is that the case? Why is okay? Maybe this is it. I have to specify. Let's see if if that was the issue. It might have been the case that I had to reinvoke since I renamed it because of the fact that this was already defined. Let's see. Let me do this. And bam, that's it. That was it. The problem was primary methods. This operator here isn't the operator that you're trying to invoke. This operator, the primary method, is basically the same name as the method combination that you're defining. Okay, that makes sense because of the fact that you need to specify this in order for it to actually go in and creating it. Okay, okay, okay. So this here now all works and makes sense. We could go ahead and show this off here. So once we do this, just for purposes of definitions, if we go ahead and run now an instance of the make2 class, you can see that this is basically doing what we did earlier with the short form notation, which is why I prefer the short form just because it makes things easier for me. I don't have to really remember all these nuances. But if you can't do it, you need the long form. Just make sure that one of the lists in the method group specifiers is including the method combination name the class as being the primary method in the order in which you want that actually to be invoked. The around and before and after stuff that you're seeing here, this is kind of standard stuff that basically you could provide a keyword argument and allow users to provide additional information that can then be used later on in the forms that you're invoking. But this piece here in the method group specifier here, this is what was throwing us off earlier. So um, with this information, I'm setting the stage kind of for another um, kind of group. Unfortunately, I didn't have enough time to actually go through the L parallel use case. Um, but that's going to be a table for next week. Um, so that's all I have for today. Um, does anybody have any questions?
I have no questions. That was just really interesting to watch that get debugged. And so, thank you.
Thank you.
Thanks, Ron.
All right. So if there aren't any other questions, I will see you guys next week, and I hope you all enjoy the rest of your Saturday. See ya.
Hey, Ron, do you want to chat for a bit, or do you got to get going?
Oh, no, 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 no. I'm just exiting the stream.
Okay.
Give me a second.